Can we tile the plane with copies of the Koch snowflake? The snowflake is usually formed by starting with an equilateral triangle and constructing a Koch curve outward around each of the edges of the triangle. We can tile the plane with equilateral triangles that share a common edge, but if we use those to construct Koch snowflakes, the two Koch curves along the common edge will point into the opposite triangle, causing the snowflakes to overlap. What we need is a different way to construct the snowflake. Here is a version of the snowflake showing the three Koch curves that form the boundary. We can draw a regular hexagon around the outside of the snowflake. If we construct Koch curves inside the hexagon along each of the 6 edges, then in the limit, these 6 Koch curves will coincide with the 3 original Koch curves from the equilateral triangle. This illustrates how we can form a Koch snowflake by starting with a regular hexagon rather than an equilateral triangle. Now, if a regular hexagon and an equilateral triangle share a common edge, we can form a Koch snowflake from both the hexagon and the triangle. But the iterations in constructing the Koch curve outside the triangle and the iterations in constructing the Koch curve inside the hexagon will be exactly the same iterations. The result will be 2 snowflakes that fit perfectly together like 2 pieces in a jigsaw puzzle. This now gives us a way to tile the plane with Koch snowflakes using regular hexagons. First, we construct regular hexagons that have only vertices in common, but no common edges. The regions between the hexagons can be filled with equilateral triangles. The hexagons and triangles now tile the plane. This is an example of a semiregular tessellation, or sometimes called an Archimedean tessellation. If we now construct Koch snowflakes from the hexagons and triangles, the result will be a tiling of the plane by snowflakes of 2 different sizes. Each large snowflake has an area 3 times that of the smaller snowflake. The plane can also be tiled with regular hexagons in which exactly 3 hexagons meet at each vertex. This is called a hexagonal tessellation and is one of 3 regular tilings of the plane. Can we use this to create a tiling with Koch snowflakes? Here are 3 hexagons in such a tessellation. Unfortunately, if the Koch snowflake iteration is applied to these 3 hexagons, holes will appear. The holes can be enclosed inside an equilateral triangle. If Koch curves are now constructed inward along each side of this triangle, we get the Koch anti-snowflake, and this will encircle all the holes. So we can fill the holes between the 3 snowflakes with an anti-snowflake. Now in our hexagonal tessellation of the plane, if we construct Koch snowflakes from each hexagon, the result will be a tiling of the plane with Koch snowflakes and Koch anti-snowflakes. So we have 2 ways to tile the plane with Koch snowflakes. One uses a semiregular tessellation to produce a tiling of Koch snowflakes of 2 different sizes. The other uses a hexagonal tessellation to produce a tiling of Koch snowflakes and anti-snowflakes.